Hello friends, in my previous video, I had completed practice set 2.1, 2.2, 2.3. Now in this video, I will explain all examples from practice set 2.4 and also solved examples. Now let us start. Let's recall some important formulas here. If a is greater than 0, b is greater than 0, then root of ab is equals to root a into root b. Next, in first bracket a plus b into in second bracket a minus b, then a square minus b square. Next, root of a square is equals to a and root of a square is equals to a. Now next, multiply first example root 2 in bracket root 8 plus root 18 bracket complete. Now here is a simple multiplication. Root 2 into root 8 means what? Root of 2 into 8 plus root 2 into root of 18 means what? Root of 2 into 18. Now next, root of 2 into 8 means what? Root of 16 plus root of 2 into 18 means what? Root of 36. Now what is the root of 16 is 4. Root of 36 is 6. 4 plus 6 and that's equals to 10. Okay. Next example, multiply. In bracket root 3 minus root 2 into 2 root 3 minus 3 root 2. Now here root 3 into this whole bracket means what? Root 3 in bracket 2 root 3 minus 3 root 2. Next minus root 2 into again this whole bracket, that is a minus root 2 in bracket 2 root 3 minus 3 root 2. Okay. Now see this multiplication. Root 3 into 2 root 3 minus again root 3 into 3 root 2, that is a minus root 3 into 3 root 2. Next multiplication, root 2 minus root 2 into 2 root 3, that is a minus root 2 into 2 root 3. Next multiplication, minus root 2 into minus 3 root 2, this minus and minus that will become plus, that is you will get here root 2 into 3 root 2. Okay. Now see this here. This root 3 into root 3, you will get here 3. 3 into 2. Okay, then you will get here 6. Next multiplication, 3 root 3 into root 2. Root 3 into root 2, both of them have the same order. We can write root of 6. Next multiplication, here is again 2 root 2 into root 3. Both of them have the same order. Therefore, in root of 2 into 3, you will get here root 6. And hence, you will get here minus 2 root 6. And root 2 into root 2. Then you will get root of 4 and root of 4 is 2. And hence, it is a 2 into this 3. Then you will get here 6. Next simplification, 2 into 3 is 6, minus 3 root 6, minus 2 root 6, plus 3 into 2, then you will get here 6. 6 plus 6, then you will get 12 minus 5 root 6. Now next, binomial quadratic surd. Root 5 plus root 3, 3 by 4 plus root 5 are the binomial quadratic surds form. Root 5 minus root 3, 3 by 4 minus root 5 are also binomial quadratic surds. Now study the following examples. First, in first bracket, root a plus root b bracket complete into next bracket, root a minus root b bracket complete. Now again here a plus b, a minus b in that form. Therefore you will get here root of a square minus root of b square. Square and root get cancelled. Then you will get here a. Again here root and square get cancelled. And therefore the product of these two bracket is a minus b. Next, in first bracket root 5 plus root 3 into next bracket root 5 minus root 3. Again here root of 5 bracket square minus root 3 bracket square. Again square and root get cancelled. You will get here 5. Square and root get cancelled. You will get here 3. 5 minus 3, that's equals to 2. Next, in first bracket root 3 plus root 7 into root 3 minus root 7. Then you will get again here root of 3 bracket square minus root of 7 bracket square. And hence here you will get here 3 minus 7, that is equals to minus 4. Okay. Next multiplication, 3 by 2 plus root 5 in first bracket, 3 by 2 minus root 5 into second bracket. Then here a plus b, a minus b, that a square means what, 3 by 2 bracket square minus root 5 bracket square. Okay, 3 by 2 bracket square means what, 9 by 4. And again root 5 bracket square, again square and root get cancelled, you will get here 5. Next simplification, this 4 into 5, you will get here 20, that is a 9 minus 20 upon 4, and that's equals to minus 11 upon 4. The product of these two binomial sets, that is a root 5 plus root 3 and root 5 minus root 3, is a rational number. Hence, these are conjugate pairs of each other. Each binomial sets in the conjugate pair is the rationalizing factor of other. Note that for root 5 plus root 3, the conjugate pair of binomial set is root 5 minus root 3 or root 3 minus root 5. Similarly, for 7 plus root 3, the conjugate pair is 7 minus root 3 or root 3 minus 7. Remember this, the product of conjugate pair of binomial sets is always a rational number. Now, rationalization of the denominator. The product of conjugate binomial sets is always a rational number. By using this property, the rationalization of the denominator in the form of binomial set can be done. Now see this example. Rationalize the denominator 1 upon root 5 minus root 3. Now the conjugate pair of root 5 minus root 3 is root 5 plus root 3. Now multiplied here the numerator and the denominator by root 5 plus root 3. Then here you will get 1 into root 5 plus root 3 is a root 5 plus root 3, and to the denominator root 5 square minus root 3 square. Next root 5 plus root 3 and the square of root 5, you will get here 5, and the square of root 3 you will get here 3. 5 minus 3, then you will get here 2. Therefore root 5 plus root 3 upon 2, and hence the denominator is a rationalized. Next example, rationalize the denominator 8 upon 3 into root 2 plus root 5. The conjugate pair of 3 root 2 plus root 5 is 3 root 2 minus root 5. Therefore multiplied numerator and the denominator by 3 root 2 minus root 5. Next 8 into in bracket 3 root 2 minus root 5 upon here 3 root 2 plus root 5 into 3 root 2 minus root 5. Then you will get here 3 root 2 bracket square minus root 5 bracket square. Next multiplication, that is 8 into 3 root 2 minus 8 into root 5. Now the square of 3 root 2 bracket square, 3 square is a 9 and root 2 square is a 2, and root of 5, its square is a 5. Next 8 into 3, 24 root 2 minus 8 root 5. 9 into 2, 18 minus 5. Okay. and hence you will get here 24 root 2 minus 8 root 5 upon 13, and hence denominator is a rationalized. Now we'll start the practice set 2.4. First example, multiply root 3 into in bracket root 7 minus root 3. Next, root 5 minus root 7 into root 2. Next, in first bracket 3 root 2 minus root 3 into 4 root 3 minus root 2. Now first example, root 3 into root 7 minus root 3. Simple multiplication is here. That is a root 3 into root 7 means you will get here root of 3 into 7 minus root 3 into root 3. That is the root of 9. You will get again root of 9 is 3. Therefore here is a 3. A root of 3 into 7 means what? Root of 21 minus 3. Now next. Root 5 in bracket root 5 minus root 7 into root 2. Simple multiplication. Root 5 into root 2 minus root 7 into root 2. Root 5 into root 2 means what? Root of 5 into 2 minus root of 7 into 2. You will get here a root of 10 minus a root of 14. And hence the answer is root 10 minus root of 14. Next multiplication. In first bracket 3 root 2 minus root 3 into next bracket 4 root 3 minus root 2. Now the multiplication 3 root 2 into this whole bracket, that is a 3 root 2 in bracket 4 root 3 minus root 2 minus again this minus root 3 into this whole bracket minus root 3 into in bracket 4 root 3 minus root 2. Now the next multiplication 3 root 2 into 4 root 3 minus 3 root 2 into root 2. Okay. Next minus root 3 into 4 root 3. Next minus and minus, that will become plus root 3 into root 2. Next multiplication 3 into 4 12. Root 2 into root 3, that is the root of 2 into 3. Next 3 into root 2 into root 2, that is the root of 2 into 2 minus 4 into root 3 into root 3, that is the root of 3 into 3 plus next root 3 into root 2, that is the root of 3 into 2, then you will get here 6. Next, that is a 12 root 6 minus root of 4 means what? 2. Then here you will get root of 4 is a 2, therefore 3 into 2. Next minus 4, root of 3 into 3 means what? 9, and root of 9 is 3, that is 4 into 3, and last root 6. Now next 12 root 6 minus 3 into 2, then you will get here minus 6, minus 4 into 3, you will get here minus 12 plus root 6. Next simplification 12 root 6 plus 1 root 6, then you will get 13 root 6, and minus 6 and minus 12, then you will get minus 18. See this simplification 13 root 6 minus 18. This is the answer. Now next example. These are the examples for rationalize the denominator. Okay. Now we'll solve one by one. The first example, rationalize the denominator. First is 1 upon root 7 plus root 2. Now the solution. The conjugate of root 7 plus root 2 is root 7 minus root 2. Next multiplied numerator and the denominator by root 7 minus root 2. Okay, 1 into root 7 minus root 2 is root 7 minus root 2, and root of 7 plus root 2 into in next bracket root 7 minus root 2 is root of 7 bracket square minus root 2 bracket square, and the next root 7 minus root 2 to the denominator you will get here 7 minus 2. That is, a square of root 7 is 7. Square of root 2 is 2. 7 minus 5, you will get here 5. And hence the answer is root 7 minus root 2 upon 5. And hence the denominator is rationalized. Next example, 3 upon 2 root 5 minus 3 root 2. Okay, now the solution. Conjugate of 2 root 5 minus 3 root 2 is 2 root 5 plus 3 root 2. Again multiplied numerator and the denominator by 2 root 5 plus 3 root 2. Okay, now next multiplication, 3 in bracket 2 root 5 plus 3 root 2 upon. Again here the square of 2 root 5, that is the square of 2 root 5 bracket square minus square of 3 root 2, that is the 3 root 2 bracket square. See the simplification. 3 in bracket 2 root 5 plus 3 root 2. Now next square of 2 root 5 bracket square, the square of 2 is 4 and the square of root 5 is 5. Okay, therefore here you will get here 4 into 5. And the next, the square of 3 is 9 and the square of root 2 is 2. Therefore 9 into 2. And hence to the denominator you will get here 4 into 5. Numerator as it is, that is 4 into 5 20. 9 into 2 18. Next keep this numerator as it is. 20 minus 18 you will get here 2. And hence denominator is a rationalized. It is a 2 is a rational number. And hence this is the answer. Now next, rationalize 4 upon 7 plus 4 root 3. The conjugate of 7 plus 4 root 3 is 7 minus 4 root 3. Now again multiplied numerator and the denominator by 7 minus 4 root 3. Then here you will get 4 in bracket 7 minus 4 root 3 and to the denominator 7 plus 4 root 3 into 7 minus 4 root 3, that is a 7 square minus in bracket 4 root 3 bracket square. Next multiplication, 7 into 4 you will get here 28. 4 into 4, 16 root 3. 7 square is 49 and the square of 4 is a 16 and the square of root 3 is a 3. Okay, 16 into 3, then you will get here 48. Okay, 49 minus 48. Keep this numerator as it is. 49 minus 48, you will get here 1. Okay, and hence the denominator is rationalized. Okay, and that rational number is 1 here. And this is the answer. That is the 28 minus 16 root 3. Now, next example. Root 5 minus root 3 upon root 5 plus root 3. The conjugate of root 5 plus root 3 is root 5 minus root 3. Now multiply here the conjugate of root 5 plus root 3, which is root 5 minus root 3 to the numerator and the denominator. Next multiplication here you will get root 5 minus root 3 into root 5 minus root 3 means what, root 5 minus root 3 bracket square and to the denominator. Again root 5 bracket square minus root 3 bracket square. Then next the square of root 5 minus root 3 means what, root 5 bracket square minus 2 into root 5 into root 3 plus root 3 bracket square and to the denominator. Square of root 5 is 5. Square of root 3 is 3. 5 minus 3, then you will get here 2. Next, root 5, its a square is a 5. Root 3, its a square is 3. 5 plus 3, then you will get here 8. Next, 2 into root 5 into root 3. That is a 2 into a root of 15. 5 plus 3 is 8. 5 minus 3, then you will get here 2. Next, you can take 2 as a common from the numerator. Then in bracket you will get here 2 in bracket 4 minus root 15 upon 2. Now we have 2 to get cancelled, and hence you will get here 4 minus root 15. Denominator is rationalized. Okay, and the answer is 4 minus root of 15. Here the denominator is 1, and which is the rational number. And in this way we have completed the practice set 2.4. Now we'll see in the next video. Till then, goodbye.